Hello students, and welcome to the lecture on strings and character array. After the lecture, we will be able to learn the following objectives. Understand strings and character arrays. Define reading strings from the keyboard. Explain how to print strings on the screen. Discuss the importance of terminating null characters. Explain various string library functions and list of strings. Understand command line arguments. Let's start with a brief introduction to strings and character array. The C programming language provides a data structure called the array, which can store a fixed size sequential collection of elements of the same type. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. An array of characters is commonly known in most computer programming languages as a char array. A char array is a sequence of characters recorded in memory in a long line of consecutive addresses that can be quickly accessed by using the index of an element within the array. Like many arrays of scalar data types, the benefits of using a char array are to allow for fast random access and for replacement of values at arbitrary positions within the array.
Now, a string in C is a one-dimensional array of characters, and just as you would work with a one-dimensional array of integers or a one-dimensional array of floats, you would work with the strings, right? So, as you can see, using code blocks, I have saved a file and I've given it the name strings.c, and in this tutorial, through this program, we're going to see how we can declare a string and how we can display it on screen using printf function. And we're going to talk about a couple of more things, so let's just get right into this. And on line 1 in this file, I have the stdio.h header file. On line 2, I have the main function, and then between the curly braces for main, I have two executable statements. On line 4, I have declared an array of characters, and I've given it the name str. And you can make out that the data type of this array is char, so all the elements in this array have to be characters, right? And I haven't specified the size of this array. I have left the square brackets empty, and then I have the assignment operator, and then I have typed in my string within a pair of double quotation marks. So this is the first thing that you need to know about strings, that whenever you work with them in C, you have to put your strings within a pair of double quotation marks, right? So single quotes won't work as they do with some other programming languages like PHP or Python. In C, if you're working with strings, and you have to put your strings between double quotes, right? So that's a rule and you have to remember that. And then I have my string, which consists of two words, hello and world, and there is a space character between the two words. And then I have the exclamation symbol at the end of the second word, which is world, right? And then I have the semicolon to terminate the statement. On the next line, I have the printf function that's going to display the string on screen, and I've used the %s format specifier. So you use %d for integers, %c for characters, %f for floats, and you have to use %s for strings, right? And then after the comma symbol, I have the name of the string, which is str, and you don't have to type in your brackets here or anything. You just have to specify the name of your array or string, which is str, right? So let me save the file, and when I click on build and run, I see that my string is displayed in the output window, which is hello world, right? And the exclamation symbol is there too.
Now let's talk about strings. A string in the C language is simply an array of characters. Strings must have a null character after the last character to show where the string ends. A string can be declared as a character array or with a string pointer. String.h or strings.h. The C language provides no explicit support for strings in the language itself. The string handling functions are implemented in libraries. String I/O operations are implemented in std, io.h, putS, getS, etc. A set of simple string manipulation functions are implemented in string.h, or on some systems in strings.h. The string library, string.h or strings.h, has some useful functions for working with strings, like string copy, string category, string compare, string length, string collate, etc. String copy. This library function is used to copy a string and can be used like string copy, destination source. It is not possible in C to do this. String 1 equals string 2. String copy will not perform any boundary checking, and thus there is a risk of overrunning the strings. String compare. This library function is used to compare two strings and can be used like this. String compare, string 1, string 2. If the first string is greater than the second string, a number greater than null is returned. If the first string is less than the second string, a number less than null is returned. If the first and the second string are equal, a null is returned. Look at the example as shown. String category. This library function concatenates a string onto the end of the other string. The result is returned. Take a look at the example here. String length. This library function returns the length of a string, all characters before the null termination. Take a look at the example. Memory compare. This library function compares the first count characters of buffer 1 and buffer 2. The function is used as shown on the screen. The return values are: if buffer 1 is greater than buffer 2, a number greater than null is returned. If buffer 1 is less than buffer 2, a number less than null is returned. If buffer 1 and buffer 2 are equal, a null is returned. String literals. A string literal, also known as a string constant, is a string of characters enclosed in double quotes, such as "to err is human, to really file things up requires a computer." String literals are stored in C as an array of chars, terminated by a null byte. A null byte is a char having a value of exactly 0. Do not confuse the null byte \0 with the character 0, the integer 0, the double 0.0, or the pointer null. String literals may contain as few as 1 or even 0 characters. Do not confuse a single character string literal, for example A, with a character constant A. The former is actually 2 characters because of the terminating null byte stored at the end. An empty string consists of only the null byte and is considered to have a string length of 0 because the terminating null byte does not count when determining string lengths. Let's now talk about the character arrays. Within some programs, an array of characters could be used as the basis for the implementing of a string class or advanced string data type. In the C programming language, strings are actually handled in a way very similar to a char array, in which a consecutive sequence of characters forms the string, informing the program that the string has ended with a null character. Most of the functions for which a char array is used involve text input and output, simply because of the size of a scalar character is unpredictable from one system and compiler to another in many languages, and so cannot be relied on to hold integer values beyond a certain range. Empty array. An array is empty if it has 0 elements, although not all computer languages allow an array to be declared in this way. Another interpretation of an empty array is an array in which all the data elements are either null, 0, or undefined, depending on the programming language being used. The other meaning of an empty array is an array that has been initialized so it contains no data, or is filled with values that indicate no data is present. This is because in languages such as C, when memory space for an array is allocated, it still contains any residual data from previous programs or files that might have occupied the space. Character array initialization. Character arrays that will hold strings allow a shorthand initialization. Remember that one has to make sure to make the array long enough to include the null terminator. In C, a string of characters is stored in successive elements of a character array and terminated by the null character. The null character is written using the escape sequence 0. The ASCII value of null is 0, and null is defined as a macro to be 0 in stdio.h, so programs can use the symbol null in expressions if the header file is included. The remaining elements in the array after the null may have any garbage values. When the string is retrieved, it will be retrieved starting at index 0, and succeeding characters are obtained by incrementing the index until the first null character is reached, signaling the end of the string. We will now discuss how to read strings from the keyboard. The C library provides 3 streams, stdin, stdout, and stderr for input and output. stdin is an input stream used to receive input from the user. stdout is the normal output stream, and stderr is a second output stream, traditionally used to report error messages or other unexpected output. Printf function. Printf is the usual method for writing information to the screen, similar to Pascal's write and write in, declared in stdio.h. This copies its argument to the standard output stream, stdout. Usually characters sent to stdout will be sent to the screen. To write the value of a variable, use a %sign followed by a letter indicating the type of the variable. To write the value of variables of other types, use %f for doubles and floats, %c for chars, and %s for strings. Scanf function. Scanf reads and interprets characters from the standard input stream stdin, which usually receives what the user types at the keyboard, declared in stdio.h. Simple uses of scanf might look like as shown here. Flush. Flush flushes a stream, waits until all pending output is written, declared in stdio.h. The most common use is as shown. Flush can be used with any stream open for writing. Let's now talk about how to print strings on the screen. When one is saying input, that means to feed some data into the program. This can be given in the form of a file or from a command line. C programming language provides a set of built-in functions to read given input and feed it to the program as per the user requirement. When one is saying output, that means to display some data on the screen, printer, or in any other file. C programming language provides a set of built-in functions to output the data on the computer screen, as well as one can save that data in text or binary files.
Let's write a simple program to display some text on screen. Let me create a file. I'll save this as, let's create a folder also. I'll call this C programs. Yeah, this will be a print instruction. Print instruction.c. Okay, as a good practice, let's begin with a comment which passively communicates what we are working on. So C program to print a text string on screen. Let me also include author name, that's me, I'm Krishna Teja. Let me also write website www.vidyarthi.org. Cool. Now let's begin our program. Let's include the library file #include stdio.h Then let's write our function void main. Then we'll print f. Hi, hearty welcome from Vidyarthi team. Close it with the statement terminator. I'll also include get ch over here so that there's a pause when you actually execute this program. Okay, compile and run. Hi, hearty welcome from Vidyarthi team. Cool, it's working well.
The standard files. C programming language treats all the devices as files. So devices such as the display are addressed in the same way as files, and given files are automatically opened when a program executes to provide access to the keyboard and screen. The scanf and printf functions. The int scanf, const, char pointer format, function reads input from the standard input stream stdin and scans that input according to the format provided. The int printf, const, char pointer format, function writes output to the standard output stream stdout and produces output according to a format provided. The format can be a simple constant string, but one can specify %s, %d, %c, %f, etc. to print or read strings, integer, character, or float respectively. There are many other formatting options available which can be used based on requirements. For now, let's look at a simple example which makes things clear. When the code is compiled and executed, it waits for you to input some text when you enter text and press enter. The program proceeds and reads the input and displays it as shown. Here it should be noted that scanf function expects input in the same format as you provided %s and %d, which means you have to provide valid input like string integer. If you provide string string or integer, then it would be assumed as wrong input. Second, while reading a string, scanf function stops reading as soon as it encounters a space, so this is test are 3 strings for scanf function. The getChar and putChar functions. The int getChar void function reads the next available character from the screen and returns it as an integer. This function reads only a single character at a time. One can use this method in the loop in case one wants to read more than one character from the screen. The int putChar, intc function puts the past character on the screen and returns the same character. This function puts only single characters at a time. One can use this method in the loop in case one wants to display more than one character on the screen. When the code is compiled and executed, it waits for you to input some text. When you enter text and press enter, the program proceeds and reads only a single character and displays it as shown. The getS and putS functions. The char pointer getS, char pointer s function reads a line from stdin into the buffer pointed to by s until either a terminating new line or EOF. The int putS, constant char pointer s function writes the string s and a trailing new line to stdout. When the code is compiled and executed, it waits for you to input some text. When you enter a text and press enter, then the program proceeds and reads the complete line till the end and displays it as shown. Now let's talk about the importance of terminating a null character. A null character in computer programming is a character with the value of 0. It is different from the numerical 0, which is part of the standard printed character set. Null is actually a control character with the index of 0. It is used to indicate that a variable, class, or pointer is empty, undefined, or not initialized. Many programming languages use the null character to indicate that a value has not been assigned to a variable, pointer, or class. The value of null is often defined within the programming language's core libraries as the value front/0, which translates into a single blank character. The programming language known as C uses the null character to great effect to save memory space. The null character is used as the end of a string of characters, also called a null terminated string. This allows the program to store a string with the need for only one extra byte to hold the null terminator. The null character could not be displayed and was not used for any other purpose, so this system worked well. The terminating null character in strings is very important. Every string operation checks the presence of the null character to determine the end of a string. Look at the table on the screen to illustrate the importance of the terminating null character in strings. Now let's talk about the various string library functions. Char pointer, string copy, char pointer s, constant char pointer t. Copies the string t into character array s and returns a pointer to s. Copies string s2 into string s1. Char pointer, string category, char pointer s, constant char pointer t. Concatenates the string t onto the end of string s. The first character of t overwrites the null character at the end of s. Concatenates string s2 onto the end of string s1. Size t, string length, constant char pointer s. Returns the number of characters in string s, excluding the terminating null character. The special unsigned type, size t, is used instead of plain int to cater for the possibility of arrays that are longer than the maximum representable int. Returns the length of string s1. int string compare, constant char pointer s, constant char pointer t. Performs a lexicographical comparison of strings s and t and returns a negative value if s is less than t, a positive value if s is greater than t, and 0 if s is assigned to t. Return 0 if s1 and s2 are the same, less than 0 if s1 is less than s2, greater than 0 if s1 is greater than s2. Char pointer, string chr, constant char s, int, c. Returns a pointer to the first occurrence of character c in string s. If c is not present, then null is returned. Now let's talk about the list of strings. Strings are often needed to be manipulated by a programmer according to the need of a problem. All string manipulation can be done manually by the programmer, but this makes programming complex and large. To solve this, C supports a large number of string handling functions. There are numerous functions defined in string.h header file. Few commonly used string handling functions are getS function and putS function. Functions getS and putS are two string functions to take string input from user and display string respectively. Though getS and putS function handle string, both of these functions are defined in stdio.h header file. Array of strings. An array string is one element in a collection of variables, including character strings, that is used in different kinds of computer programming. The array is defined as a sequence of variables that have the same name but are uniquely identified by a secondary designation. Variables in the array share attributes. An array of strings is a sequence of variables that hold multiple characters, which are referred to as strings. An array string is one single string that is included in the array. Array of character pointers. Before one understands the concept of arrays and pointers, let's consider the given example, which makes use of an array of 3 integers. When the code is compiled and executed, it produces the result as shown here. There may be a situation when one wants to maintain an array, which can store pointers to an int or char or any other data type available. The declaration of an array of pointers to an integer is as shown. This declares PTR as an array of max integer pointers. Thus, each element in PTR now holds a pointer to an int value. Now let's talk about the command line arguments. The command line arguments are handled using main function arguments, where argument C, or agrc, refers to the number of arguments passed, and agrv array is a pointer array, which points to each argument passed to the program. Here is a simple example which checks if there is any argument supplied from the command line and takes action accordingly. When the code is compiled and executed with a single argument, it produces the result as shown here. The argument supplied is testing. When the code is compiled and executed with 2 arguments, it produces the result as shown. Too many arguments supplied. When the code is compiled and executed without passing any argument, it produces the result as shown. 1 argument expected. It should be noted that argument 0 holds the name of the program itself, and argument 1 is a pointer to the first command line argument supplied, and pointer argument n is the last argument. If no arguments are supplied, argument C will be 1. Otherwise, and if one passes 1 argument, then argument C is set at 2. 1 passes all the command line arguments separated by a space. But if the argument itself has a space, then one can pass such arguments by putting them inside double quotes or single quotes. Let's look at the example once again, where one will print program name and one also passes a command line argument by putting inside double quotes. When the code is compiled and executed with a single argument separated by space but inside double quotes, it produces the result as shown. Now in the end, let us summarize what we have learned in this lecture. The ASCII value of null is 0, and null is defined as a macro to be 0 in stdio.h, so programs can use the symbol null in expressions if the header file is included. C programming language provides a set of built-in functions to read input and feed it to the program as per requirement. An array string is one element in a collection of variables, including character strings, that is used in different kinds of computer programming. It is important that syntax for a string array is different in each specific computer programming language. One of the aspects that make an array of pointers valuable as a programming tool is that the pointers can reference any type of data available. The pointer is a data type in itself, even though its only purpose is to point toward another data type.